This is a test. Test 1, 2, 3. Okay. Okay. Screen. Hi again. So, where we left the last time, we left to implementing the client tracking logic inside the client command, the parsing and stuff like that. We cannot combine anything still because we were here in tracking.c implementing the first data structures that we need, like the prefix table, which is initialized here. But when we enable tracking, we created a new function that actually we call a new function that doesn't yet exist at all, which is enable BCAST tracking for prefix. Just takes the client and the prefix line. And we could probably start from here. No, actually we still need the new structure, struct type def struct tracking. No, this is tracking list. Let's call it tracking list, which is the one that we outlined. Okay, let's change terminal here so that the first position I will put the design document. Yeah, that's this is the okay. We call the client-side caching BCAST broadcast state, but yeah. BCAST state. Yeah, okay. Okay. That's quite simple. And yeah, so we also will need here in disable tracking. We need to implement cleanup for the broadcasting mode. Let's check if okay, already in unlink client we cleared the tracking status here, so it's okay. The client when the client is freed, we are sure that this function gets called, and here we will implement this. Take note about this thing. Okay. This is our to-do list here. So far. Yes. Okay. Okay, now we have the BCAST state, and this will be useful when we implement this function here, which was called wait, this is always an SDS, so we just can simplify this implementation here. It's just called from this function, so okay, this is our prefix. So here we need to think about what we want to do in case the same client is subscribed again against the same prefix, because it is possible like a misuse like this. So client tracking on prefix foo. In this way the client will go twice inside the list, which is not nice. And if we want to check when the client is upon registering of a new prefix in the list, this is going to be an on check, and this sucks. So probably we need to rethink this stuff here, and maybe also makes the clients rux, the client pointer here. Yeah, after all, maybe it's better. Let's check what happens in case we will change our idea again. Okay. Okay, so we have our state here, and we create the entry if we create it. At this point, now that we have the prefix, if we didn't have one, we need to subscribe this client here. So what we do is Rax try insert BS clients unsignature, not C, but the pointer to C, because C is a pointer, is our client pointer. We want to consider this as a string, so the pointer to C, which means basically it is pointing at the address that our C pointer is stored, and size of C, the size of the pointer itself. And we want to associate it with, I think, null. Yeah, and null again, which is the old value that we don't want. And if this function fails, we don't care, in case it fails. Okay, this makes sense. Now, in the cleanup, I have two options here. If I don't want to store anything in the client structure in order to avoid making it bigger, well, but it's better to actually change this here. Client tracking prefix nodes. Rax client tracking prefixes. Yeah, should make sense. Client tracking prefixes. Otherwise, in the cleanup, we have to scan all the registered prefixes, not just one where the client is subscribed, in order to perform the cleanup. So, when we do disable tracking here, at this point we can implement this function. Okay, if Rax insert, because this should return true when it is able to insert. Let's see, Rax generating insert, yeah. 0 is not done, otherwise element is inserted and 1 is returned. I hope that here everything is working. Let's check. Yeah, looks like it works. And this guy here, yeah, the audio is working. Okay. So if we are able to insert this client, it means that is a new subscription, so we want to also add our prefix here. So Rex insert client tracking prefixes. Why is client tracking? It's Just tracking would be better, but anyway, at this point it's like that. Okay. No. Okay. So the cleanup. When this client disconnects, we want to do the following thing. It's a lot of boilerplate to write. Again, the same thing to set up an iterator. So this could be reduced with macros, but in the end you finish writing a different language, which can be confusing. So yeah, it's lame. It's again the same thing when you need iterate. But after all, it's not so terrible. Probably a function in order to combine start and seek would be nice, but anyway. So, Rux next. Okay. Yeah. We remove it from here, and if after we remove this client, this state is empty, so if at this point Rux sides the BS clients, it's 0, there are no longer clients subscribed here. What we want to do is Rux free BS clients, Rux free BS keys, Z free BS, so we free everything, and Rux free prefix table ri key len null, and we remove the prefix completely from here. Okay, so if this client is in broadcasting mode, we need to unsubscribe it from all the prefixes it is registered to. Was it the last client? Remove the prefix from the table. Okay. Okay, this function became more complex, but it's not rocket science. So far we have enabled broadcasting, we have disabled of the tracking, and this is called from here, but at this point it's quite a lot of code without even trying to compile anything, so everything will break in terrible ways. Yes. What's here the problem? Client tracking prefixes. Unexpected expression. CRC. Okay. 4. More args. Too few arguments for function. Realloc. Prefix. How nice static typed languages are with all these checks for free. What's the problem here? Client. Okay. What's this client here? This is the client in the redirection, probably. This is all broken because it should be C flags. Yeah, and what is this client thing? The client, yeah. What the fuck? Yeah, but here is initialize when used. So it's 20. Okay, it's here used in the implementation of client kill, but so let's declare this more locally. Let's check. Yeah, it was declared on the top level of the function without good reasons. Rux free prefix table kill end because it's Rux remove and stupid spelling mistake. Too many arguments. Prefix enable broadcast for client. Oh fuck. Okay, this should be like that at this point. Okay, so we have a symbol way in order to specify the empty prefix here. So it's okay, no big problem at all. Non-prefixes. Okay. So we did an incremental improvement here, and but still we are not doing anything useful because we need to populate the keys and then implement a function in order to send all the collected keys before returning to the event loop. So we have to build our big reply and send it the same to multiple clients. Okay, I will take just 5 minutes pause and I will return back here. Okay, I'm back. So, war screen again. So yeah, we coded, but nothing works because we didn't implement the main logic yet, which is okay. Let's check what is our entry point for in order to remember the keys that the clients are modifying. Okay, this function is called after the execution of a read-on command. This is not interested from the point of view of broadcasting. Okay. Here, for example, we need a top comment, send tracking message. What is doing this function? We need to describe every function with a top comment in order that our version of the version of ourselves that we return here in 6 months will not have to read what's going on here. Okay. This function is called from signal modified key or other places in Redis when a key changes value in the context of keys tracking. Our task here is to send a notification to every client that may have it. Okay, this is exactly what we need for our entry point to remember also the prefixes, to remember the keys that were modified in a given prefix. Tracking validate key. So we get the key object, we get the IDs, and if there are no IDs, we return. Okay. But before doing that, if racks sides prefix table greater than 0, remember key to broadcast, SDS key, SDS len, SDS key. Let's check 10 seconds if there is a better name. Yeah, it's okay, because we actually have to remember the key of the invalidation messages that you want to broadcast, and it is a good idea that there is broadcast name inside this function. So void tracking, remember key to broadcast char key name size t key len. This function is called when a key is modified in Redis. And in the case we have at least one client with the BCAST mod enabled, its goal is to set the key in the right broadcast state if the key matches one or more prefixes in the prefix table. Later, when we return to the event loop, we will send invalidation messages to the clients subscribed to each prefix. Okay. How complex we are making this code? You know, it's still like a joke. It's just 351 lines of code, and broadcasting is making it a lot more complex, but still it's very simple code in order to have an interesting feature. This also shows how the number of lines of code that you produce every day is not exactly the same depending on the language, because if you are writing C code for system programming, C language, every line is very meaningful and requires some thought. Okay, so in order to make this working, we need to scan our invalidation table. Our prefix table. Okay, so this is the prefix table. Scan it, and okay, here the thing is very simple. If the length of this key is greater than the length of the prefix itself, then it is impossible that there is a match. Otherwise, if the key with the prefix and the key name are the same for the length of the prefix, actually if they are not the same, then we don't have a match. If memCompare returns non-zero, we don't have a match again. Here we have a match. Okay, what we do if we have a match? We take the BCAST state here, which is the pointer associated with this key in the radix tree, and we try to insert, because there could be already a copy of it, in the keys of this prefix, we put this key. Okay? And Okay. So at this point, using this function, we have populated our prefix table with all the prefixes and all the clients and all the keys that were touched during, we say during the next event loop, but actually it is between the time the last time send the notifications to the current time. So we need now the function that will send all this broadcasting information and will empty completely our table. Okay, there is another thing that we need to do. No, okay, we already, if the client disconnects, we clean up it. So we should have only valid pointers already in the racks of the clients. Yeah. Okay, so in the very end, limit usage slots, and then we write this function here. Tracking, broadcast, invalidation, messages. What is the point of this function? Tracking, broadcast, invalidation, messages. That must be, by the way, public here, because we will call this function from in the event loop callback. Okay, so this is the goal of this function. Now, a very interesting thing to note is that we could optimize this function a lot by creating a single big reply and then copying this reply to every client buffer. However, if you check here, depending on the version of the protocol, we have to do one thing or the other. But the interesting part is the same, because which is the big part of the reply is here, is the buffer, is the array of key names. So we can create just the common part between the two protocols, and then for each client we prefix this common part with this or with this. Yeah. Okay. Also, this logic here is exactly the same. Looks like that we will have to refactor this function here, send tracking message, in order to take or a key and a key len or the protocol, or just the protocol needed to emit the array. Yeah. So we move this here, so that this is the common part, this is a common part. Key name and key len int proto send tracking message proto 0 here and 0 again. This is not a protocol but it's a key. Okay, so what is the proto argument? Is true, is non-zero. The function will assume that key name points to a buffer of key len bytes already expressed in the form of Redis REST protocol, representing an array of keys to send to the client along as value of the invalidation. This is used in BCAST mode in order to optimize the implementation to use less CPU time. Okay. And how we should modify this function here? So if proto we do something, otherwise we do that. Again, if proto we do that, else we do that. What we do in case of proto? And in this case we do add reply array len add reply bulk. Anyway, here there is a problem because actually the reply here is exactly this. So it was more complex without any need. There is no need to create any static object or whatever here because it's just add reply C buffer. Yeah, it's an array with a single string. Okay, past errors. But in that case, instead, we just need to do add reply. And now that these two are exactly the same, it means that actually this part is here. And this is no longer needed. Okay, should be it. The color scheme using in the terminal app. To be honest, I don't remember. I think I created it myself or something like that. Let's check what color scheme I'm using. So this is presentation. ANSI colors, it's just, yeah, I set manually the selection. I did this manually, changed the cursor to be blocked probably or something like that, but I think I created it like manually, like here. And the color scheme of Vim itself, colors, the color scheme of the syntax highlighting is desert. I have no idea where if I downloaded it or it's default color scheme, but it's called desert. Okay, so it compiles without errors, and we have this function to send tracking message, reusing the logic that we have for non-broadcasting mode. Now, what we can do here, okay, to start, let's run the prefixes. Okay, and after we send, okay, we take the state here, and we will have to send all the keys to all the clients that are in this BST. Okay, now we probably, in order to optimize this very well, may resort to having an SDS object that we populate with the Redis protocol directly. Let's see if this is a good idea. So this is an array, we said. So we need this to start. Later probably we will need to optimize. We should optimize this in order to use the stack. If the profiler will show that it's a win. And here we should have a number. So, okay, actually we create this. So we have the asterisk, then we want to have the number, but what is using? Okay, we use this function here that should be fast enough. Oh, actually we have faster implementations. Yeah, we have a faster implementation of that. So what we do here instead is this. Okay, ll2string should be our fast implementation of this. Yeah. Yes, because this will handle 2 digits every time. Okay, ll2string. So ll2string is destination, sides, and the value of the long. The length of the array is BS keys, the number of keys that we have. Okay, now that we have the length, we create the asterisk, then sds_cat_len buff len, then crlf characters, and at this point we can populate the remaining with all the names of the keys. So okay, it's the same logic that we have here, exactly the same stuff that we have, but with the trivial change of ll string buff size of buffer and re2 key len, and the protocol is the bulk string prefix character cat sds_cat_len proto comma re2 key len. So we pass the key here and then the termination here. Okay. So we are filling basically we emitted the RESP2 and RESP3 protocol, which in the case of the array, because RESP3 is a perfect subset of RESP2, so the array is the same in both protocols. And we created this stuff here. You know what is the slow part of this code, which is hidden from the code itself, is the fact that SDS will require the pre-allocation. So actually, when we create the string here the first time, so it's a good idea to have a guess about the amount of space that each key will take, and do like proto SDS make room for yeah, it's still a function like that. Proto equal SDS make room for proto rack sides BS keys, the number of keys that I have, times the average number of keys that the average length of the keys that I expect the typical user of Redis will have. But even if I do a wrong estimation here, it's not a problem, because the buffer is resized in by doubling it every time. So the problem is I don't want to start with a small buffer and do realloc, because the first reallocs, the amortized time is going to be still quite high. But I can say just I expect the average key to be 15 characters long, and I precise the buffer for this. Okay. Yeah. So, and okay, let's. No, this is not needed. Okay. Yeah, that makes sense. Yeah, at this point, maybe it is even more clear if we just cut, and cut, and we create an empty string. But actually, I think that in the latest versions of SDS, we have a way to create a new string directly of the right sides, even if it is not initialized. Maybe it's new len if null is passed. Okay, create a new string with the code. Okay, but if null is used, the init is with 0 bytes. So the init, the buffer is no, this is not what we want. Okay. So this is the best we can do. So SDS empty, make room for, and then we paste here our protocol. And once we created the protocol, we have to deliver it to each client here. Let's reuse the same iterator again. But this time we want to iterate the clients. Client, oh fuck, indentation error here. Okay, now it's correct. So our client C is obtained by copying in the C variable, which is a pointer, the key that we have here for the sides of the pointer. Now that we have C, we can proceed by sending it. Let's remember to free the proto here. Okay, then call our function, which is this one. Send the tracking message to C. The key name is actually our proto for SDSLAN proto, and yes, it is protocol. Okay. What's happening here with the indentation? It's like everything broken like that? Yeah. I don't know what happened here, but okay. Okay, in the cleanup we want to clean up the protocol that we created, and then we want to, I think the faster way is just to free BS clients and BS keys. And create it from scratch. Okay. Wow. So what we did here, disable tracking. I mean, not show, but diff. Okay, the main contribution of this commit is clearly, okay, this. Okay, broadcasting of keys in prefix is implemented. Cool. So far so good. And in the next session, we will do more. We will test if it works. We will insert this new function in the correct entry point. We will check if the cleanup is correct. We will check for memory leaks, and we will implement tests, and we will do a lot of things. Thanks for watching. I will be on Twitch for the next minutes in case you want to ask any question.